All right. We are continuing with Euclidean. So today we'll be focusing on Theorem 2. Right, so Theorem 2 has three shapes that you have to. I'll start with that, but they'll only require you to prove one, right? Always, they always require you to prove one. So you have the first one being like this. Obviously, this is the center, right? And write O. And then you have another one. Don't mind my ugly circles. The other one will be the center is here, and then we have something like that. Right, this is the center. And then the last one, we have something like this. The center is here, then we have something like that. Right? Yeah. So all these theorems, it's Theorem 2. So what is Theorem 2 saying? The Theorem 2 is simply saying that the angle, this represents angle, right? The angle at center is equal to 2 times the angle at the circumference. The angle at circumference, right? So that is your Theorem 2, right? So it says that this is the angle at center. They say that this angle is 2 times this angle. This angle is 2 times this angle. This is the circumference. Remember when we did the introduction to the Euclidean, I told you that the circumference, it means that the points that are touching the circle, the outer part of the circle, right? So that is the circumference. So this one says that the angle at the center, which is this one in this case, is 2 times that angle. So it means that if this angle is 20 degrees, this one will be 40. If this angle here is 60, this one will be 30, because this one at the center is 2 times the one at the circumference. If this one here is 80, we expect that one to be 40. The one at center is 2 times the one at the circumference, right? So you must be familiar with all these three shapes. They all belong to one theorem, which is Theorem 2. But when they ask you to prove it, they always ask you to prove it with this one, not these two. These two, you use them for application only, right? So we will now prove, it's a bit long, and they always ask you to prove it because it can be a bit tricky for some people. So remember, what I'll do, I won't write down everything, but let me see, this is your circle, and you have something like this, and they tell you that there is the center. So let's say this is A, this is B, and that is C, right? And let's say this one is M. So you're given something like this. Obviously, always when you start with proving anything, you always start with given, right? So you will write your given, you will write given, what are you given? You're given a circle with point A, B, and C on the circumference, with circle, you're given a circle with center M. You can label all those things that you are seeing there, right? So we'll skip that step of giving. Then from there, the next thing that we follow is the RTP, which is required to prove. What is it that you're required to prove? You're required to prove that this angle A angle MP is 2 times A angle CP, right? So we are required to prove that A angle MB, which is this angle, is 2 times the angle A angle CB, right? That is what we are required to prove, that this angle is 2 times that angle, right? So by so doing, remember what we follow is what is construction, if we have anything to construct, right? What are we constructing? We're going to join C and M. So we write the join CM and extend to any letter that you like, right? And say T, right? So we join C to M. Remember that always when we join and then we extend it to T. This is what I'm saying. Everything that we're saying in construction, remember not to draw it with solid lines. You draw it with dashed line, right? It must be dashed lines because that thing was not originally there, right? It's something that you are putting there so that you make things easier for you to be able to prove. And then this side you put 1, you put 2, you put 1, you put 2, so that it's easier for you to be explaining to the person who will be checking. Then from there, what do we do? Now we are starting with the actual proving, right? You prove, right? So when you prove, what will you say? You can see that here we have two triangles, right? We have this triangle ACM, right? It's the first triangle. It's like you have something like this, right? It's ACM. And then you have another one this side going straight like that, and then like this, right? You have two triangles like this. I hope that makes sense, right? Let me try and draw them properly. You have two triangles, you have C, you have M, this is CM, and then you have A here, and then it comes back. And then you have another one, you have B here, then it comes back, right? So this is what you have. You have two triangles like this, if we take each triangle apart, right? So what I want you to remember before we start proving is this. Remember that we have something called an isosceles triangle. And in an isosceles triangle, we have two angles that will be equal here because they are opposite, the sides which are equal, right? That is what I want you to know. And another thing that I want you to know is that the radii or the radii of the circle, they are all equal. So once you know that and you remember that, you are sorted, because the one of the radii I told you on the previous video, right? So on proving, what will we say? The first thing that we say is what is that AM being this one, right? AM being this one. Remember that this is the center, will be equal to MP. And what is the reason? The reason is what is the radii, right? They are equal, they are both radius. And we said all the radius of the circle, they will be equal, right? So the reason is what is radii, right? So we are done with that one. And then the next one that you have to prove is what? The next one you have to prove is that angle A is equal to angle C1, right? And the reason is what? It's an isosceles triangle that I just told you about, because also CM is also a radii, right? So it will also be equal to AM and MP. So if these are equal, then it means that these angles should be equal. I hope that makes sense, right? If these are equal, these angles should be equal. But the reason we don't say isosceles triangle, the reason is what is angles. These angles are equal to opposite sides, right? It's angles opposite equal sides, right? So that is the reason. Angles opposite equal sides. That is the reason. And then after doing that, now that we know that A is equal to C1, it means that we can replace A with C1 because they are equal, right? But before I even confuse you, here we have M1. We say that angle M1 is equal to angle A plus angle C1. What is the reason? Is the angle that is exterior. Remember that when we have a triangle and then you have an angle outside here, this angle is equal to this one plus this one. What is the reason? The exterior angle of a triangle, right? So that is the reason. This is the stuff that you learned on in earlier grades. So what will we say? Now that we said that angle A is equal to angle C1, it means that here I can substitute and say that angle A is C1 because they are equal. So instead of me saying that angle M1 is equal to angle A plus angle C1, because I now know that they are equal, I'll say that it is equal to angle C1 plus angle C1, right? And what is the reason? The reason is the exterior angle of triangle, right? I hope we are still together. So it means that all in all, at the end, what we have angle M1 being equal to 2 angle C1, because this is what these are like terms, right? It will be something like that. I hope you understand so far. So everything we've done so far, you take that, because everything we did, we were applying it on this side, right? So you take the same thing, you apply it on this side. What will you say? You start by saying that angle C2 and angle B are equal, and the reason is what? Angles opposite equal sides. And from there, what will you say? You say that angle M2 is equal to angle C2 plus C2, because this is the same as C2, right? So I hope that makes sense, right? And I'm not confusing you. So at the end, what will you do? You can you will do that, but because of space, I'll say same applies on triangle CMP, right? Being this triangle CMP, same applies on this triangle. but you don't have to write same applies. You have to do the same thing we did, right? Which is easier. So at the end, we'll have what? Angle M2 being equal to 2 times angle C2, right? And at the end, what you do, you have to add these two. You say that angle M1 plus angle M2 is equal to 2 angle C1 plus 2 angle C2. What are we simply doing here? We are simply adding this to that. We are adding this M to M2. We know that M1 is equal to 2C1, that is why we put it there, and that this one is equal to this, that is why we put it there. Then from there, angle M1 plus angle M2, you can see that they are giving you angle M, right? Angle M1 and angle M2, they're giving you angle M, which is A, angle MP. They're giving you the whole of this angle, right? I hope that makes sense. If we add these two, they will give us the whole of this angle, right? And we said the whole of that angle is what? Is A, angle MP. And if we add angles C1 and C2, they're giving us the whole of that angle, which is A, angle CB, right? So it means that I can come here and substitute and say that this one is A, angle MB, because when I add these two, they will give us this angle, right? And then this side, you take out the common factor, which is 2, right? Because we are adding, the common factor is 2, right? You can't add C1 and C2, those are not like terms. So what do? We take out the common factor, which is 2, and then we add C1 and C2. And C1 and C2, when we add them, we get this angle. So we will say that is angle ACB, right? So by so doing, we have proved that angle AMP is equal to 2 times angle ACB, which is what we have. If you look at this, it is exactly the same as what we were required to prove up there, right? So we have proved that the angle at center is equal to 2 times the angle at the circumference, right? I know that it might be a lot and it might not make sense. Repeat the video and I'll give you exercises. Remind me to give you exercises of how to show you exactly how they apply this thing, right? So with that being said, I will quickly go to Theorem 3. Theorem 3, what's nice about it is that you don't have to prove anything. You just have to know how to apply. The Theorem 3 says that the angle in semi-second, that is the reason you use when you apply Theorem 3, angle in semi-second. So what is Theorem 3 saying? Theorem 3 is saying that when you have an angle that is passing, when you have a diameter, right, and you have an angle that is subtended by the diameter. When we say subtended, we simply mean that the angle that is facing the diameter, right? So it says that that angle will be 90 degrees, right? So it says that the angle that is subtended by the diameter, remember the diameter is the chord that is simply passing through the center. The angle that is subtended by this diameter is 90 degrees. But it's converse, if you remember what the converse is. The converse is simply saying that if we are not told that this is 90 degrees, and they tell you that you have a chord that is passing through the center, right? And you are given an angle, automatically, even if they don't tell you, you know that this should be 90. Even if they don't tell you, you know that this should be 90. Why does this should be 90? Because it is at the circumference, it's subtended by this, and this is passing through the center. If it's not passing through the center, this can be 90 degrees. So that is Theorem 3. I hope that makes sense and you understand. So that will be it for this video. What I'll do as quick when you're done, right? You let me know so that I give you exercises, because it's useless if we keep on proving theorems and we don't apply them, right? So you let me know. I will give you exercises to show you how you apply these theorems and how they ask questions. And from there, we will go on to do Theorem 4 up until Theorem 9, right? Thank you.